Okay, so today what we're doing is looking at the length of an arc. So we're going to calculate the length of an arc using radian measure. Okay, so today what we're going to be doing is everything that we do in circles and this topic from now on, we're going to be using radians with our calculators. That's why we did our exit ticket beforehand. Okay, so you'll be successful today if you can use the formula for arc length. You can solve for the missing angle or radius of a sector, and you can interpret arc length in real context and sketch diagrams to support calculations. So radian measure is defined from the length of an arc of a circle, and we can use radians to find the arc length of a circle. So what we have is all the work on circles, we're using radians like I just said. So we can find the length of an arc by comparing the arc length of the circumference and the central angle to the whole revolution. Now, when we're talking about finding the length of the arc, we're finding this bit here. So if we had to cut out a piece of pizza, we're finding the length of the crust of the pizza. That's what we're finding. Now, the formula that we use for the length of the arc is L for length equals r theta, where r is our radius and theta is our central angle subtended by the arc, okay, as we see in the diagram. So how we prove that this formula works is we have that our arc length, which we call L for length, divided by our circumference of a circle, is equal to the angle that we call theta divided by the whole revolution, so the angle of a whole revolution. Now, when we talked about radians last lesson, we know that radians are measured exactly with pi, and we have that 2 pi is equal to 360 degrees. So a whole revolution is 2 pi. So our arc length, we have our L equals a circumference formula, which is 2 pi r, so our circumference of a circle is 2 pi r, equals our angle theta divided by that whole revolution of 2 pi. Okay, so like I said, 2 pi is our whole revolution because we have that 2 pi is equal to 360 degrees. Okay, but we're using everything in terms of radians. What we're doing here is we're trying to find a formula where L is the subject. So to make L the subject, we need to times by 2 pi r to the other side. So we'll get L equals theta lots of 2 pi r divided by 2 pi. Now, hopefully we can all see how this cancels out, but we have our 2 pi on the top, 2 pi on the bottom. They disappear and we write our formula as r theta. Now, you don't really need to know that proof, but it's pretty cool to know how it happens. And you don't need to remember that formula either because it is on our reference sheet. Okay, so you always have it with you. What we're going to be doing is we're going to be looking at how to find that length of the arc formed. We're also going to be looking at how we can use the length of the arc to find the radius or to find the unknown angle as well. So for our first example, we want to find the length of the arc formed if it subtends an angle of pi on 4 at the center of a circle of radius 5 meters. So our first thing that we should do is write out our formula L equals r theta. And off to the side, we should really state what our r equals, which is 5, and our theta equals pi on 4. So we can easily now substitute these into our formula. We get L equals 5 times our angle of pi on 4. Okay, this is the same as 5 times a quarter for any of you that don't have the new calculator. If you have the FX 8200, you can simply just go 5 times pi on 4, and your calculator will tell you that your answer is 5 pi on 4. But we should all be able to see how that works. Now we're finding an arc length, so our arc length is in terms of meters. Once you have that example copied down, flip to the next page for me. That make sense? No one has any questions? It's pretty straightforward, right? Okay, so that question was pretty straightforward. Now, what I said at the start is we want to do everything with our angles in terms of our radians with our angles. What we have in this question is we want to find the length of the arc formed if the central angle is 30 degrees and the radius is 9. So first things first, we write out that formula L equals R theta. We get R equals 9. But we have that theta equals 30 degrees. Now we need to change this to be in terms of radians. We can't operate with our 30 degrees. So to change from degrees to radians, we times by pi over 180 degrees. Now, if you have the new calculator, you can just go 30 times pi on 180 and it will give you that theta equals pi on 6. If you don't have the new calculator, you just need to work out what 30 on 180 is and put your pi with your numerator. Okay, so 30 divided by 180 is 1 on 6. Put your pi in your numerator. Now that we know these two things, we can substitute them into our formula. So we get our arc length is 9 times pi on 6. Okay, so we'll have that this is 9 lots of pi on 6. However, we can simplify this. Okay, what does 9 on 6 simplify down to? 3 pi over 2. Okay, and we need to make sure that we include our units with our centimetres. So if you have the new calculator, you could have just gone to 9 times pi on 6 straight away, and it will simplify it down to 3 pi on 2. If you don't have the new calculator, you could have just gone 9 on 6 and then put your pi with your numerator to simplify it straight away. Any questions with that first one? Okay, the next example we have is that we've been told that the area of a circle is 450 centimetres squared. We want to find in degrees and minutes the angle subtended at the centre of the circle by an arc of 2.7 centimetres. Okay, key thing here is we're going to be converting into degrees and minutes from our radian answer. Now, the first thing that we're told here is we're told our area of a circle. So we're told that A equals 450 centimetres squared. Now, an area of a circle formula is something that you should have stored in your memory bank. Okay, area of a circle formula, does anyone remember it? It is pi r squared. Okay, so we need to store that in our memory bank. So we know what A is. We're told that A is 450. So we'll have 450 equals pi r squared. And from here, we can make R the subject. Is what we are doing. Okay, so to make R the subject, what we need to do is we need to divide by pi. So when we divide by pi, we have R squared equals 450 divided by pi. Okay, then we want to square root. I'm not plus or minusing the square root because we want a distance for our radius. And our distance is always going to be positive. So that means it's just going to be R equals the square root of 450 on pi. From here, we now know our radius. We also have our arc length. So we can use our arc length formula, L equals R theta, where we have that L is equal to that 2.7 and we have R is equal to that 450 on pi. So we can substitute those in. So we'll get 2.7 equals the square root of 450 on pi times by theta. Okay, from here, we want to make theta the subject. So how we make theta the subject is we divide by the square root of 450 on pi. So what we'll have is that theta equals 2.7 divided by the square root of 450 over pi, Now, this is where we put it into our calculator. So we put 2.7 divided by the square root of 450 over pi into our calculator. And what we get is that theta is 0.225596547. And that is in terms of radians. Did the question ask for radians? No, it asks for degrees. So what we have to do from here is go that theta equals 0.22559 ... And to get it from radians to degrees, we multiply by 180 on pi. So what we're doing here is we're converting from radians to degrees. When we put that into our calculator, what we'll get is that theta equals 12 degrees 55 minutes and 32.63 seconds. And the question asked us to the nearest degree. So it's 12 degrees and 56 minutes.